Suppose that the distance of fly balls hit to the outfield in baseball is normally distributed with a mean of 248 feet and a standard deviation of 50 feet. We're asked two questions. The first is if one fly ball is randomly chosen from this distribution, what is the probability that this ball traveled fewer than 198 feet? And the second question, the follow-up, is if one ball is randomly chosen, what is the probability that the ball traveled more than 216 feet? In both instances, I want to start out by looking at my standard normal distribution as a picture. So I'm going to draw a standard normal distribution curve, just sketch it out. And in this curve, I'm going to label it so that my mean, right in the middle, is given to be 248 feet, and one standard deviation to the right of my mean and one standard deviation to the left of my mean is calculated by adding 50 feet, the standard deviation, to 248 feet, giving me 298 feet, and subtracted from 248 feet, giving me 198 feet. I'm also going to put in here while I'm at it that at 248 feet at my mean, this is where my z-score is 0, right? 298 feet, one standard deviation away, that's where my z-score is 1. And at 198 feet, one standard deviation away on the left, this is where my z-score is -1. I have my setup, and now I'm ready to answer the two questions, or at least start to. So for question A, what is the probability that the ball traveled fewer than 198 feet? Looking at my standard normal curve, and my x-axis, which is the feet right here at which the ball traveled, where am I looking for fewer than 198 feet? Well, the balls being fewer than 198 feet is to the left of that marker. Right here, the area under the curve to the left of 198 feet is the area that is going to tell me the probability or percentage that I'm looking for. The percentage of the curve shaded to the left of 198 feet is going to give me that probability that the ball traveled fewer than 198 feet. And the cool thing is that 198 feet lands directly on one standard deviation away from the mean. And so I can use my empirical rule. My empirical rule tells me, what does it tell me? Well, first of all, it tells me that the band that's in between 198 feet and 248 feet, that band is 34% of the curve. Right? That band right there in between one standard deviation and the mean represents 48% of the total curve being underneath. 34% of the area under the curve falls in that band right there. Well, then looking at my shaded picture, I know that 50% of the area on the left of the mean take away 34% in that black band is going to be what I use to calculate the area of the blue shaded region, right? 50% lies less, I'm tongue-tied today. 50% of the curve is shaded to the left of the mean, right? 50% of the curve is shaded to the left of the mean. So if 34% of that 50% lies in that black band, that means that the leftover part, or 50 minus 34%, or 16%, lies right here in this blue area. So, what is the probability that a random fly ball travels fewer than 198 feet? Well, that probability is 16%. That completes part A, and we're going to move on to part B. For part B, we're asked, what is the probability that a random fly ball travels more than 216 feet? Okay, so first thing is we have to look at our picture. Where is 216 feet relative to 248 feet? Well, 216 feet lies to the left of 248 feet. In fact, it's actually even a little closer to 198 feet. So 216 feet is right in here. I want to know what is the probability that if we choose a ball, it has traveled more than 216 feet. And that's equivalent to saying, let's go ahead and let's find the area under the curve greater than 216 feet. We now have a visualization of what we're trying to do. 216 feet, unfortunately, doesn't lie on a straight standard deviation. It's not like one standard deviation away. So we can't use our empirical rule. So we're not going to be able to use that 34%. Instead, what we're going to do is we're going to need to use our z-table and our z-scores. So let's calculate what would be the z-score that corresponds right here to 216 feet. To get that, I'm going to use that z-score rule. And the z-score rule says that z equals x minus the mean divided by the standard deviation. Or in other words, the z-score for our particular value being 216, is 216 minus our mean, which is 248, divided by 50. This formula will transform our feet into a z-score. So we take 216 minus 248 divided by 50. What's that give us? 216 minus 248 is negative 32. Sorry about that, negative 32. And if we divide negative 32 by 50, that gives us negative 0.64. That tells me that the z-score corresponding to 216 feet is negative 0.64. And that makes sense in my picture because that's about halfway or a little closer to the negative 1, but it's in between negative 1 and 0. So the number we got makes logical sense in our picture. It is this z-score of negative 0.64 that we want to use on our z-table to calculate the area that corresponds to the band in between that z-score and the mean. So we're going to go right now and we're going to use that z-table, and it's going to give us an area value. And that area value corresponds to the band between the z-score and the mean. So let's go figure out what the area is for that red band. So we have negative 0.64. So we're going to look z equal negative 0.64. And we know from using this chart that there's no negative values for z. We look for the positive value because of symmetry. All right, so we're just looking for the positive value, 0.64, and where those two places, one row meets one column, we get a score of 0.23891. Everybody see that? 0.23891. So 0.23891 is the area under the curve in between the z-score negative 0.64 and the z-score z equals 0, or the mean. It's the area of that red band right there. In the context of what we're talking about, that means that 23.891% of the area under the curve falls in that red band. Now, is that what we're looking for? Not quite. We're looking for the total area greater than 216. We're looking for the purple area, part of which is included in that red, but we're looking for the bigger purple area. So what do we need to do? Can you see it? We know how much is in this spot. Do we know how much area is to the right of the mean? We do, right? To the right of the mean, that's 50%. So if I take 50% and I add that to the extra red band piece that's to the left of the mean, those two values combined will give us the total for our percentage more than 216 feet. So we are going to add 50% to 23.891%. And when I add those values up, I get 73.891%, meaning the probability that a ball travels more than 216 feet is 73.891%. Now we're asked to round our answer to the nearest tenth, and so I would input 73.9%. If you have any questions, don't hesitate to reach out and let me know. Good luck.